There is a recipe for freezing a planet solid, and you already know the first step. Take the carbon dioxide out of the air. That step is correct. Everything you assume comes after it is wrong. 650 million years ago, this world is frozen from pole to pole. Ice at the equator, at sea level, over open ocean. And the sky above that ice is not thin, and it is not clear, and it is not starved of carbon. It holds more carbon dioxide than any air complex life has ever met. So what does the readout say on a planet buried in ice? Carbon dioxide climbing toward 100,000 parts per million, roughly a tenth of the entire atmosphere, about 240 times what you breathe. Oxygen, low, genuinely uncertain, and for once not the thing that kills you. Temperature, a global average that may have sat near -50. A tenth of the air is greenhouse gas, and the ocean is frozen to the equator. Both are true in the same moment. That is not a contradiction in the story. That is the story. So where does the jump actually put you on sea ice? Not near the pole. At the equator on the sea ice with a kilometre of it under your boots and an ocean beneath that has not seen the sky in millions of years. And the first thing that is wrong is the surface. You expect snow. There is no snow. The air is too cold to carry water vapor and too dry to give any back. So snow sublimates straight off the tropics and leaves the ice bare, hard, blue-gray, bubbled through like frozen soda, scoured smooth. Stephen Warren's group worked out in 2002 what that tropical ice would look like and what it does. It flows. Kilometre-thick sea glaciers grinding down out of the mid-latitudes toward the equator, a couple of kilometers a year, because there is nowhere warm left for them to stop. Then you notice the second thing. There is no smell. None at all. Not sea, not stone, not rot. Smell needs something breaking down, and nothing on the surface has ever been alive. So how fast does this start costing you? It starts at your feet, and it starts immediately. You are not standing on cold ground. You are standing on ice, and ice pulls heat out of you roughly 90 times faster than air does. Your boots are a rounding error. The planet is drinking your core temperature straight through the soles. And this is the good part of the world. Equatorial noon, the warmest hour of the warmest place on a snowball. Earth sits somewhere around 20 below. There is no better latitude to walk to. You are already standing in it. Your body's answer is to abandon the edges. Blood pulls back from your fingers, your toes, your face to defend the organs. It is the right call, and it is why exposed skin here freezes in minutes. Then the air takes the rest. Every breath you push out is fully saturated with water. The air you pull back in has almost none. You are being wrung out through your own lungs, one breath at a time. So you need heat and you need water, and you are standing on the largest supply of water in the solar system. Where do you get either? Not from the ice. Melting a single liter of it and warming it inside your own body costs more heat than your entire body produces in an hour. Eating snow on a snowball, Earth is a withdrawal, not a drink. So you make fire. With what? This is the part nobody pictures. There is nothing to burn. Not scarce, absent. Land plants are 200 million years away. There is no wood, no peat, no coal, no reachable oil, no dung, no fat, no bone. The entire chemistry of setting something alight to keep warm depends on a biosphere that has not been invented yet. On this planet, the only thing that makes fire is a volcano. Life is still here, and it is underneath you, in hot vents on the seafloor, in cracks, in thin patches of ice over shallow, nearly landlocked water where just enough light gets through for algae to keep photosynthesizing. Eukaryotic life comes through this. It comes through it by not being on the surface. You are on the surface. So this is the worst winter in Earth's history. Fine. When does it break? Here is the reframe, and it is why this episode is not really about cold. This is not a winter. A winter is a wobble in a system that pushes back. Nothing here is pushing back. In 1969, the Soviet climatologist Mikhail Budyko built one of the first energy balance models of Earth's climate and found a cliff in it. Ice is bright, so ice reflects sunlight, so ice makes more ice. Push the ice edge past roughly the mid-latitudes, and that feedback stops being a trend and becomes a runaway. The model takes the whole planet all the way down, and then it just sits there, not an event, a state, and a stable one. You are standing at the bottom of that model. In 1992, Joe Kirschvink gave the state its name in its cruelest detail. Earth normally runs a thermostat Warm, wet rock weathers faster. Weathering scrubs carbon dioxide out of the air. The planet cools itself. Backwards, it saves you. A cold Earth scrubs less, carbon builds, and the world warms itself out of trouble. It has rescued this planet again and again. But the supercontinent Rodinia had broken apart across the tropics, so when the ice came, it formed over ocean. The rock went under ice, sealed. The scrubber did not slow down, it stopped. The thermostat is not losing the fight, it has been unplugged, and in 2010, Francis McDonald's team took away the last excuse. In the Yukon, glacial deposits, ice-rafted debris, scratched stones, dated to 716.5 million years, with the magnetism locked into the rock recording where it formed, about 10 degrees from the equator, at sea level. So the question was never how cold it gets. It is how long a planet stays somewhere once. Nothing is pushing it back. The first freeze, the Sturtian, held for roughly 57 million years. You are standing on the second one. So what finally breaks it if the thermostat is gone? The volcanoes. They never stopped. They keep venting carbon dioxide into an atmosphere that has no way left to remove it for tens of millions of years, and it simply piles up. In 1998, Paul Hoffman and Daniel Schrag read The Ending Out of Rocks in Namibia. Carbon isotopes in the limestone stacked directly on the glacial rubble told them the freeze did not fade out. It ended abruptly once outgassing had shoved carbon dioxide to about 350 times modern levels, at which point the ice edge crosses Budyko's cliff going the other way, and the feedback that dragged the planet down now runs in reverse at full speed underneath the heaviest greenhouse atmosphere this world has ever assembled. Raymond Pierrehumbert's modeling of that aftermath puts surface temperatures near 50 degrees. The ice is gone in a few thousand years. The new ocean is dark, absorbs everything, and pulls carbon out of the sky so fast that limestone precipitates straight out of seawater with no living thing involved. Meters of it laid down directly on glacial debris. You could put your hand on that contact today. Ice Age gravel, and then, with no gap you can see, tropical seafloor. So the thaw is not a rescue arriving. It is the same event finishing its sentence. And then it happens again, 100 degrees. That is the verdict. Not seconds, not eras, 100 degrees of swing, from a global average near minus 50 to a surface near 50, with no survivable point at either end, and none anywhere on the way between them. The cold has you in hours. No fuel, no liquid water, no shelter, no food, no warmer latitude to walk to because you are already standing in the warmest one. And the only door out of the cold opens directly into the other thing. There is no version of this where you hold on long enough. Holding on is how you reach the 50. 2 freezes, 2 thaws. Ice, then fire, then ice, then fire, and nowhere in any of it a window wide enough to be called a place to stand. The ice is not what you have to survive. The ice is what you have to survive first. So why come here at all if there is nothing in it but 2 ways to die? Because you are downstream of it. Everything after is. Ask what a kilometer of moving ice does to a continent over 57 million years. It planes it flat. Snowball glaciers are a leading candidate for scraping kilometers of rock off the top of the world, and the hole left in the record is so large it has its own name, the Great Unconformity. A billion years of missing history sitting in the wall of the Grand Canyon where anyone can walk up and look at it. Rebecca Flowers and Francis McDonald have spent years testing when it happened, and when the meltwater finally ran, it carried all that ground-up rock into the sea. Phosphorus. Nutrients, a wiped slate and a fully loaded ocean at the same moment. What comes next is oxygen rising, then the Ediacarans, then the Cambrian explosion, the event this whole series opened on. Season 1 begins, more or less, where this episode stops. We are not survivors of this. Nothing that could be called us was anywhere near it. We are what the meltwater built. There is a recipe for freezing a planet solid. It turns out to be the recipe for everything that came after.